Hi all, I am Aishwarya presenting you the topic IP security policy. In this presentation we will be discussing about IP security policy, two databases, security association database and security policy database, and IP traffic processing. Now let us see what is IP security policy. Fundamental to the operation of IP security, it is the concept of security policy applied to each IP packet that is transferring from the source to destination. IP security policy is determined primarily by the interaction of two databases. The first one, Security Association Database, and the second, Security Policy Database, that is SAD and SPD. This section provides an overview of two databases and summarizes their use during IP security operation. Architecture of IP security. The figure illustrates the relevant relationship of two databases. Here we can see IKE. It is the collection of documents describing the key management scheme for use with the IP security. And the next one is the SPD. It is Security Policy Database, and SAD, Security Association Database. And the next component is the ESP. It is the Encapsulating Security Payload, which consists of an encapsulating headers and trailers used to provide encryption or combined encryption or authentication. Before going to the Security Association database, we must know what is Security Association. A key concept that appears in both authentication and confidentiality mechanism for IP is a security association. An association is a one-way logical connection between a sender and a receiver that affords security services to the traffic carried on it. That is, it is a one-way logical connection between the sender and receiver that provides services during the transferring of IP packets. And if a peer relationship is needed for two-way secure exchange, then two security associations are required since it is a one-way logical connection. A security association is uniquely identified by three parameters. That is, we can see the three parameters of the security association. The first one is security parameter index. It is a 32-bit unsigned integer assigned to this SA and having a local significance only. And the second one is IP destination address. This is the address of the destination endpoint of the SA, which may be an end user system or network system such as firewall or router. That is the address of destination endpoint of the SA. The third one is the security protocol identifier. This field from an outer IP header indicates whether the association is a AH or ESP security association. It's all about security association. Next is security association database. In each IP security implementation, there is a nominal security association database that defines the parameters associated with each SA. A security association is normally defined by the following parameters in an SAD entry. We can discuss one by one. The first one is the security parameter index. It is a 32-bit value selected by the receiving end of an SA to uniquely identify the SA. That is, it is a 32-bit value selected by the receiving end for uniquely identify the security association. The second one is the sequence number counter, a 32-bit value used to generate the sequence number field in AH or ESP header. That is security number counter. The third one is the sequence counter overflow. A flag indicating whether overflow of a sequence number counter should generate an auditable event and prevent further transmission of packet on this SA. Next one is the anti-replay window. It is used to determine whether an inbound AH or ESP packet is in replay. The next, AH information, authentication algorithm, key lifetimes and related parameters being used with an AH. ESP information, encryption, authentication algorithm, keys, initialization values, key lifetimes and related parameter being used with the ESP. Next, the lifetime of this security association. It is a time interval or a byte count after which the SA must be replaced with a new SA or terminated plus an indication of which of this action should occur. That is, it is an interval or a byte count after which an SA must be replaced with a new SA. Next one is the IP security protocol mode. It can be a tunnel, transport or wildcard. The last parameter is path MTU. Any observed path maximum transmission unit and aging variables. It's all about the parameters of the security association database. Now we can move to security policy database. The means by which IP traffic is related to specific security associations is the nominal security policy database. And we can say in the simplest form, an SPD contains entry for each of which defines a subset of IP traffic and points to the SA for that traffic. And in a complex environment, there may be multiple entries that potentially relate to a single SA or multiple SAs associated with a single SPD entry. That is, it in the simplest form we can say that an SPD contains entry for which defines a subset of IP traffic. That is, for an IP traffic, it may contain a subset of entries and points to an SA for that traffic. Each SPD entry is defined by a set of IP and a upper layer protocol field values called selectors. In effect, these selectors are used to filter outgoing traffic in order to map into a particular SA. The following selectors determine an SPD entry. Here are some selectors determining the SPD entry. The first one is the remote IP address. This may be a single IP address, an enumerated list or range of address or wildcard address. The second one is the local IP address. It can be also a single IP address or an enumerated list or range of address or wildcard address. The third one is the next layer protocol. The IP protocol header includes a field that designates the protocol operating over IP. It is the next layer protocol. And the next one is the name, a user identifier from an operating system. It can be any name. The last one is the local and remote ports. This may be individual TCP or UDP port values, an enumerated list of ports or a wildcard ports. Next we can see the IP traffic processing. That is, IP security is executed on a packet by packet basis. That is, security is performed on a packet by packet basis. When an IP security is implemented, each outbound IP packet is processed by a IP security logic before transmission. That is, for an outbound IP packet, the security is performing before transmission, and each inbound packet is processed by IP security logic after reception and before passing the packet contents onto the next higher layer. We look at the logic of this situation in turn. So, first we can see outbound packets. A block of data from a higher layer such as TCP is passed down to the IP layer and the IP packet is formed, consisting of an IP header and an IP body. And we can see the steps involved here by using this processing model of outbound packets. Here, the outbound packet is from any TCP or UDP. Here first we can see. The first step is IP security searches the SPD for a match to this packet. First step, the IP security is searching for the SPD. That is here. Search security policy database. And the second step is, if no match is found, then the packet is discarded and error message is generated. That is, if there is no match found, then discard the packet. Then the third step, if a match is found, further processing is determined by the first matching entry in a SPD. That is, if a match is found, then determine the policy. Here, policy. If the policy for this packet is discarded, then the packet is discarded. That is, if the by determining the policy, if the packet is discarded, then it will come to the discard packet here. And if the policy is bypassed, then there is no further IP processing. The packet is forwarded into the network for transmission. That is, if the determined policy is bypassed, then it will come into here forward packet by IP. That is, it is directly the forward to the network for transmission. And the fourth step here, by determining the policy, if it is discard, then discard packets, then bypass here forward to the network, and if it is protect, then it will come here. Then a search is made of the SAD for matching entry. Then here the search security association database. If no entry is found, then IK is invoked to create an SA with an appropriate keys and an entry is made with the SA. Then here Internet Key Exchange, IKE. If no match is found, then then IK is invoked to create an SA with the appropriate keys in the key and an entry is made with the SA. Then here, moving here, then fifth step, if the matching entry in an SAD determines the processing of packet. That is, if a match found, then it is a processing of the packet here, and we are doing encryption, authentication, or both can be performed, and either transmitter tunnel into can be transport or tunnel mode can be used. Then by doing encryption and decryption and both, then is the packet is then forwarding for transmission. That that is modem for transmission. It is the processing model of outbound packets. That is the first step. Here we are the IP security searches for an SPD entry for a match to this packet, and if no match found, then we will be discarding, and if a match found, then it is determined by first matching entry in SPD. And if the policy for the pack, then we came here, and if the then determining the policy, if it is a no match, discard, then discard the packet, bypass, then forward it to the network, protected, then search SAD, and if no match is found, then IK, internet key exchange, and if match found, then process, that means we are performing the operations and then forwarding into the network. It's about the outbound packets. Next we can move to the inbound packets. That is, an incoming packet triggers the IP security processing. Here next we can see what are the steps occurring here. The first, IP security determines whether this is a unsecured IP packet or one that have an ESP or a H header trailer by examining the IP protocol field or next header field. That is, by receiving the inbound IP packet from internet. Here receiving the IP packet, first we need to determine the packet type, whether it is a with a security or without security. Then second step, if the packet is unsecured, that is, if a packet is unsecured, the IP security searches the SPD for match to this packet. That is, without security, it moves to the search for a security policy database, and here searches for the SPD for match to this packet. If the first matching entry has an policy of bypass, the IP header is processed and stripped off, and packet body is delivered to the next higher layer such as TCP. And if it is have an policy of bypass, then the header is processed, and after that only the body is delivered to the next higher level such as TCP or UDP, etc. That is, and if the first matching entry has a policy of protect or discard, or there is no matching entry, the packet is discarded. If there is no bypass, then it will be discarded. And in case of, first we determine the packet type, and if we have a secured packet, that is secured packet, then the IP secure searches for a SAD searches for SAD for a matching entry, and if it no match found, then we will be discarding the packet, and if match found, here we will be applying appropriate ESP or AH and AH is processed, appropriate ESP or AH processing. Then the IP header is processed and stripped off. The same process, the IP header is processed and stripped off this header, and only the packet body is delivered to the next higher level like TCP or UDP. It's about the inbound packets. And so we can conclude our section. In this presentation, we discussed about IP security policy, and it can be determined primarily by the interaction of two databases. The first one, Security Association Database, and the Security Policy Database. And Security association database, it is one of the way logical connection between a sender and receiver that affords security services to the traffic carried on it. And in case of a security policy database, it contains entries, each of which defines a subset of IP traffic and points to the SA for the traffic. And we discussed what is IP traffic processing. That is, an IP security is executed on packet by packet basis. So whenever we are IP security is implementing, for each outbound packet, the process packet is processed by the IP security logic before transmission, and in case of inbound packet, it is processed by IP security logic after reception and before transferring to the packet content to the next layer. So it's all about the IP security policy. I hope you understand the topic. So thank you.